just disclaimer. So Arima saves the model at the results folder, but the mock-invest reads it from this main folder. So just make sure you go up to this and you change this part. So please change this res path to results. This is gonna be better. Hi, this is Lab 3 Part 2 demo video. First, let's go add the data. For this part, we're gonna use Google stock data. But that's embarrassing. Lab 3 Part 1. Stop right there. First, I'm gonna drop whatever I have. I have Disney and Google, and you can add Google, and let's just add Google. 5 years. I want day trading, so just one. Okay, there you go. Daily data. Now we have 5 scripts we want to showcase today. First, let's do simple moving average.
Yes, so simple moving average is a simple algorithm that takes the average of the data from a specified window size, like 5, for example. And then this window keeps moving and the average changes with every move. So for this one, we'll just do option 2, which is get buy and sell signals, because this one actually shows everything. And just follow the prompts like 5 for small window size and 20 for large window size. You'll get this visualization that shows the original data in blue, the short-term data in purple, the long-term data in orange. And every time the short and long-term smooth are like crossing over, depending on how they're crossing, you'll get a buy signal and a sell signal. So yeah, like every green triangle is like when you should buy stocks, and then every red triangle is when you should sell stocks. Okay, then we'll move on to the exponential smoothing. So this one and simple moving average are just two of our more simpler algorithms that we were using just to like play around with, just different algorithms to see which one would work best for our own stock prediction. And again, you just follow the prompts and you'll get the buy and sell signals. So for exponential smoothing, this one is like, um, hold on, sorry. This one reacts more quickly to price changes than simple moving average, and it puts more weight on the recent data points than older data points. So first it calculates the simple moving average, and then it calculates the multiplier or the smoothing factor for weighing the exponential moving average. So yeah, again, this is what you'll get after doing exponential smoothing. So yeah, after we played around with that, we decided to go with Arima, and we'll explain that right now.
Okay, so going to Arima. There's Arima imputed one. It's just like a work in progress. We try to explore imputation, but let's stick to Arima for now. It's Google again. So we get 2 choices. So this is the price over time. You can see it this is only a 5-year window period from 2024 to 2019, but you could see that the stock price is increasing over time. It has a peak on near like end of 2021, but yeah, probably during the pandemic, you know. Then this is difference where it removes all trend. It removes trend and just see the seasonality. Yeah, it just makes it stationary. You can see different stock prices, and you can see that a lot of the spikes telling you how much change is happening at that given time point and the next. So since the time series is not stationary, we have to difference it. That's why we difference it, because we did the Fuller test, and it's not significant. The p-value is pretty high. But for the purpose of this ARIMA, we box cox instead, to since it's also normalizes the data set, the time series at the same time. We have two choices. We can do auto or manual. So manual, let's try manual first. It gives you an autocorrelation and a PACF. It's called the ACF and PACF thing. ACF or autocorrelation is the correlation between one point and another point in time. So like, let's say like you can see that basically 0 to like 30 or something. You could see the autocorrelation, right? But for PACF, it's the correlation between one point in time and another point, but everything in the middle is removed. All like the effects of the correlation, the mini correlation between those 2 points are removed. So it's just the 2 points. And you could honestly, you could read ACF and PACF to find P and Q. But for this time, you could see that for ACF is kind of like tailing off, which means it's kind of like slowly going down and just not doing anything. But PACF, you could see that after lag 1, it starts to like have like a geometric. I might be wrong about this, but it's after lag 1, you could see that it's starting to have like a geometric decay. So for now, let's pick P is equals to 1. D is the order of differencing, but I put 0 because we box cox it. And Q is 0. You could see that this is our model. First, this is our model. You could see that the model looks like this. You could see that the AIC is pretty low. BIC is pretty low. You can see the intercept. You can see since it's just P equals 1, so it's just an AR model. There's no MA. And then yeah, then you could see the predictions of our model. It might look yeah. This is an AR model. That's kind of jaggy a bit, but this is our prediction. But for the purpose of our project, I also we also implemented an auto one. Also, it saves everything inside this folder, results folder device. So PKL or pickle. This is daily. The auto also searches for seasonality, so it's more accurate as well. You can see here it's performing stepwise. Who wants to minimize the AIC? Once you get the model that minimizes the AIC. You can see it's kind of better. Kind of. There we go. Yeah. Mean squared error 696. For the one on top was 1000. So yeah, the auto ARIMA is still better. And now let's try the mock invest.
Yeah, so after ARIMA, we will use the mock invest to actually implement our algorithm to see if we're buying or holding or selling at a specific time slot. So Nealson, can you continue? Yeah, it's gonna ask us how long do we want our mock investment to be? Here we can do like a slightly longer one just to see like more choices made by the algorithm. So let's say 30. And This is just the initial value of our account. Let's put 20,000. And we can also modify how many shares to buy and sell at each time. 5 or 10 would be a good option. And it's gonna ask us what is our data set interval. Right here we're using a daily. And then it's gonna ask us a small window size and a big window size. We can use a 10 and 20. Okay, and now we see the action performed by the algorithm. It is holding at first until it finds a good time to buy. And then every time it buys 10 share until it determines that it's a good time to sell. So as we can see, at the end, we got rid of all of our stocks and we actually make some money out of that. So this is our algorithm.
Thank you.